evening and welcome to this new tutorial. We are still with the relative motion analysis, dealing with the acceleration this time. The last tutorial was on the velocity. So in this simple mechanism involving this beam or bar AB is connected to this slider via the connecting rod BC. In this example, it is required to find the velocity of this slider as well as the acceleration at this very moment when this beam was making an angle 90 degrees. The given information was the omega, the angular velocity, is 4 rad per second. It is counterclockwise. And the direction of the angular acceleration alpha, it is 5 rad per second. It is in the opposite direction. It means that while this rod is going in this direction, it is decelerating. So we need first to calculate for the velocities first. We are familiar with that from the last tutorial, and we are gonna begin. We are going to start with relating the velocity B with the velocity of A, and you can see the velocity of A is of course 0. So VB is equal to VA plus omega BA cross product RB with respect to A. So VA is equal to 0. It is fixed. It's not moving. For the omega BA, it is 4K. It is positive K. It is counterclockwise. It is given 4 rad per second. For the vector RB with respect to A, it is a vector. It is an arrow which starts from A and it's at B. So as you can see here, I'm going to draw this to illustrate this. This is the vector that we have. So the length of this vector is 2, and it is going in the positive y direction, so it is 2j. So we can write this down. We can say VB is equal to 0 plus 4k cross product 2j, and this of course would equal to 4 times 2 is 8, k times j is minus I, and this is equal to minus 8I. So this is the velocity of B in vector form, and it is going in this direction. It is VB, you can indicate that. It is going in the minus direction of x, so this is minus 8I. This is minus 8I. Going now to calculate for the velocity of this slider, we can again write the equation that we know considering the arrangement of the terms. So we say VC is equal to VB plus omega CB cross product RC with respect to B. So that's what we have. That's the equation that we need to deal with to calculate for the velocity of C. So for the VB, we already know it. VB here is equal to minus 8I. For the omega CB, it is going in that direction, no problem. It is counterclockwise. We can assume this. We don't know its value, but we know its direction. So we can say it is omega CB K, no problem. For the RCB, it is a vector. It is a vector that starts from B and ends at C. So I'm going to draw this to illustrate. And the tip here is at C. And you can see it has 2 components, and they are already resolved. It has the x component, which is 0.5 minus I, and it has the y component, which is minus 2j. It is this component. This is a y component. This is the x component of RCB. For convenience, I can write this down here for you. I'm just taking advantage of this space. RCB is equal to minus 0.5 I minus 2J. Okay, so I'm going to write it here down again because I just moved the page a bit. So this is minus 0.5 I minus 2J. So that's what we have. So we're going to plug all these values in this equation, and we are going to say VC is equal to minus 8I plus omega CB K cross product minus 0.5 I minus 2J. So that's what we have. This is the equation that we are now dealing with, and we are going to multiply this and with this. So we are going to refine this to be equal to minus 8I minus 0.5 times omega CB is going to equal 0.5 omega CB, and we already know K times I is J, and omega CB times minus 2 is going to equal minus 2 omega CB. K times J is minus I, minus times minus is positive, so it's going to be equal positive I. We're going to combine the terms together, so I'm going to combine this term with this term, and I'm going to write this minus 8 plus 2 omega CB I minus 0.5 omega CB J. So that's what we have. This is the function or the term that describes the velocity of the slider C. Now we need to resolve for C. We need to manipulate a bit this value. Yes, we don't know its value, but we know its direction. So we need to find and decide on its direction. I'm going to go to the next page here. And we have here already the slider C, and as you can see, it has two components. Primarily it is going in that direction, okay? And it has two components. So the first component, which is going down, this first component is equal to, so this is the direction of VC, no problem, but this direction is equal, this component is equal to 3 over 5 VC, and for this component it is equal to 4 over 5 VC, and you can notice this component is going in the direction of minus y, so this is minus j, and this component is going in the negative direction of x, so this is minus I. All right. Now, so we can conveniently write that VC here is equal to minus 4 over 5 VCI, which is this component, and continuing to say minus 3 over 5 VCJ. So that's what we have. This is what we have regarding the velocity as a vector. So we are going to equate this with the previous relation that we came up with. So I'm going to write this down because it's going to be a long equation. So I'm going to write this down here. So I'm going to say minus 4 over 5 VCI minus 3 over 5 VCJ, and this is equal to minus 8 plus 2 omega CB I minus 0.8 omega CB J. So that's what we have right now. So we have now here we have two unknowns. We have the VC and we have the omega CV. To solve for this, we need to equate the I components together and the J components together. So we are going to write this. We are going to say minus 4 over 5, Vc equals to minus 8 plus 2 omega Cb. So this is the first equation. We equated this with that, and we are going to write that minus 3 over 5 Vc is equal to minus 0.5 omega Cb, and this is the second equation. So we have here now two equations. We can solve them and find that the velocity Vc is equal to 2.5 meters per second. This is the velocity of the slider, and the omega Cb would be equal to 3 rad per second. So we solved for these two unknowns, and we came up with these two values. In vector form, we can take these values and substitute them. We can take this value and substitute it in the original description of the slider, because it has two components. In this way, we are going to say that Vc is equal to minus 4 over 5, 2.5 I minus 3 over 5, 2.5 J. So that's what we have. Simplifying this further would yield minus 2I minus 1.5 J. So this term describes the velocity of the slider, and that's what we need. We now fulfilled the first requirement of the question. Now moving now to solving for the acceleration. So this is the interesting part. This is about the new topic, the new tutorial. So we are going to move in the same way from A to B to C. So starting first with the B as the thing that we need to calculate for its acceleration, we're going to write this down. AB is equal to AA plus alpha AB cross product RB with respect to A minus omega BA or AB, doesn't matter. I mean, for the alpha and omega, it doesn't matter the order of the letters here. It doesn't really matter. But you know, I can write it in any way. But the letters here, they do matter here. So RB with respect to A. So this is the equation that we use to calculate for the acceleration. Now for the A, we know it is fixed, it doesn't move in any way, so the acceleration of A is equal to 0, of course. For the alpha, because it is in the negative direction, so or it is clockwise, so we can write alpha AB is equal to 5 minus K, or in other words, it's minus 5K. It is minus 5K. Now for the RB with respect to A, we already found it. We already when we calculate for the velocity, so it is 2J, and we have everything for the omega BA, and you can see here it's not in vector form here, just like a value. It's a scalar value for this term. It is 4. So we're gonna plug in these values in this equation. So I'm going to write it down like this. AB in vector form is equal to 0 plus okay, I can write in this minus 5K, right? Cross product 2J minus 4 squared 2 times 2J. It's not cross product, it is just a simple multiplication. So AB in this case, the acceleration of point B is going to be equal to 10I, because K times J will yield minus I, minus times minus would read a positive value. So this is going to equal 10I. This term is going to equal 10I, and this term is going to equal to 16 times 2, 8 is minus 32. minus 32j. So this is the acceleration of point B. Still, we need to go for the AC. So AC here is equal to, using the same equation, AB plus alpha, CB or BC doesn't matter, as a vector, of course, cross product RC with respect to B, and minus omega CB squared RC with respect to B. So this is what we have. This is what we need. So for the AB, we already know it. It is here. So I'm gonna write it down again. It is 10I minus 32j. For the alpha CB, we don't know it, but we can assume its direction. We can assume it is going in that direction, so no problem. We can assume that the alpha is it is counterclockwise. So we can write this down. We can say alpha CBK, no problem. For the RCB, we have already knew it from the previous calculations for the velocity. It is minus 0.5 I minus 2j, and that's it. So, and the omega CB is, of course, we don't know it, but we can also assume its direction. But remember that we already found it from the previous calculations. It was omega CB. It was from the previous calculations. Be aware of this. We knew it, and the assumption of its direction was correct. It was 3 rad per second from the previous calculation for the velocities. So omega CB was 3 rad per second as a value, as a scalar value. Now we're gonna plug all these values, all these data in this equation. So we're gonna move on and say, okay, we have we can go and say AC is equal to 10I minus 32j plus alpha CB K cross product minus 0.5 I minus 2j minus 3 squared minus 0.5 I minus 2j. So this is the equation that describes for the AC. Solving this would give us AC equals to 10I minus 32j minus 0.5 alpha CB. We multiply this with that, but K times I would give us J, of course. This times this would give us a positive value because the minus would cancel. The minus times minus would give us a positive I. So we're gonna say this is plus 2 alpha CB. K times J is minus I times minus 2 is going to be equal to I, and this is 9 times 0.5 is going to be equal minus 4.5, but it's going to be 4.5 I, and minus 9 times minus 2 is going to be equal plus 18J. So that's what we have. This is the term for the acceleration C. So we're gonna combine the terms together, the I's with the I terms together and the J terms together, and this one and this one and this one. So AC now in the end of the day is gonna equal to AC equals 10 plus 4.5 is 14.5 plus 2 alpha CB I, and this is plus combining 18 with minus 32 would give us minus 14, and this guy is going to be plugged in here like it is, but it's going to change the sign. 0.5 alpha CB, and this is J. So this is a pretty straightforward relationship, but we need to deal with the description of AC in its vector form. Referring to the previous description of the acceleration or the velocity of the slider, it was here like that. We knew already that this is the acceleration of C. So it has two components. It has this component, which is AC 3 over 5, and this is AC 4 over 5. Pretty straightforward. And we know that this is minus J, and this is minus I. So I'm going to write this down for the description of the vector form of AC originally. So AC here is equal to AC 4 over 5 minus I plus AC 3 over 5 minus J. So AC is going to be equal to minus 4 over 5 ACI minus 3 over 5 ACJ, and that's it. So we are going to equate this term with this term to calculate for the unknowns, which are AC and alpha CB. So we are going to write this. It's going to be a long equation a bit, but we can find a way to write it completely, to occupy completely this space. Minus 4 over 5 ACI minus, this is I, I'm sorry, this is minus 3 over 5 ACJ. It's equal to 14.5 plus 2 alpha CBI plus minus 14 minus 0.5 alpha CBJ. So that's what we have. So we can equate the I terms together. So we're gonna equate minus 4 over 5 AC is equal to 14.5 plus 2 alpha CB. This is the first equation. And the second equation is minus 3 over 5 AC, which is this one, with this one. So to say minus 14 minus 0.5 alpha CB. And this is the second equation. Solving these two equations would give us alpha BC is equal to minus 12.4 rad per second, and AC in the end of the day is equal to 13 meters per second squared. So we can use this value and plug it. We can use this value and plug it here and here to come up with the vector form of AC. In this way, AC is equal to minus 4 over 5 times 13 I and minus 3 over 5 times 13 over J, and this will give us the vectorial form of AC. Thank you for watching.